Hello, back again for, I guess this would be 22, but really this is just the conclusion of the last lesson, 21. So I'm going to mark this as 21.1, I guess. I didn't want to finish up the program in case there might have been a mistake or something in there. And in fact, there were a couple mistakes. And I've weeded them out, so you don't have to see that. And now it's reduced to this. Most of this is the same. Here's the exit error. Now this is a cutesy way to test if something is equal to 0. That's the same as comparing AX with 0, but in terms of machine code, it's faster. If that OR sets the 0 flag, then AX is 0. Otherwise, AX is not 0. And then I don't need to save CX off, as it turns out. When you're entering it in by hand, it turns out that you can get fewer than CX bytes back, even though it's not the end of the block. Control Z. So I remove that pushing and popping of C, convert case, and write parse almost the same. I think this one's exactly the same. Yeah, okay. If it is, it is. If not, that's what it is now. And printing the characters out is quite easy. First, I'm saving off the 3 registers I promised not to touch. And then I'm moving again into BX the pointer to the buffer, and simply using the int21 function to print to standard out. Could have also used something that uses the file standard out, but this works, and so I used it. And this is a similar loop like the other. And it turns out it does work. Deleted it, so I'll type it all in again, which I'll do now. Okay, to the beginning. Move, read. Move into CX80, that's the size of our buffer. I like to keep it small, so just to see that, actually I should even change it to a smaller number. The smaller you make something, at least for a debug build, the more likely you're going to run into a bug in your code. If you have a great big buffer, you won't see your bugs as easily. So small is good, at least for debug. And once you're done debugging, then you can make things nice and big. BX is our standard in 0. We could use the XO there. But anyway, DX is our buffer. And then int21. Okay. Now, if with carry set, we're gonna go to an error. Don't know what that is yet. That'll be an exit. Otherwise, I'm going to check if AX is 0, that means we didn't read anything. And if that's 0, I still want to go to the same place. Wherever it is. And now, I want to put into the CX register, which is the counting register, in fact. It has a kind of a name. AX, the number of bytes we read. And I'm going to call some function. I don't know where. And then I'm going to call another function. I don't know where. Then I'm going to continue the loop. Okay, now here's a good place to quit. 11D. So I can fix up 10D and 111. Okay, so that's what we got so far. If that again means jump carry 11D is quit. If A is 0, jump do 11D, quit. Transfer into CX AX, call some function, call another function. Well, the first function will fit nicely here at 11F. So let me change that. Okay. Here's that function. Push AX. CX. Put into DX the address of our buffer. And so I've done that. Now I'm on this line. Now I don't have to put any of that byte pointer, word pointer stuff here because ALO is a byte. So it knows that this refers to a byte. And not anything bigger. To see if it's a check against little a. And if it's below that, I'll go somewhere, don't know. That means it's out of range. 7A, if I recall. If it's above that, I want to go to the same spot where it really is. Otherwise, I need to take away 20. Now, there's two ways to do this, in fact. You'll notice that if you work it out, to convert from uppercase to lowercase a number, if AX is a 41, say, and I want to convert that to a 16, that's actually equal to 41, 4, 20. Turns out, for the whole range of letters, this happens to be true. But I won't do that. I don't need to confuse. Subtract 20. Okay, so that's that bit. Track it. Now we gotta store that back into the same buffer. Alright, now we know where our next car is, which is 131. Which would be something below 131, nothing there yet. Jump above, subtract, store, 131. Increment px, we're going up in the buffer, and then we want the loop, where we want the loop to, where we moved into AL. Still got that? Yeah, still got that. 1, 2, 3. Okay. And when we're done with that looping, we store CX, and we store AX, and return. Okay, so far so good. So therefore, return. So the next location for our next function is going to be at 137. So this should be 137. Okay. Now, next function. This is just going to print out the buffer after we've modified it. Save off the registers. They're all going to get modified. Again, we need in bx the address of the buffer, so we can use the brackets. And now move A high 2, move into 2 low, so there goes that bx character in the buffer. Into 1 and increment bx, move along the buffer. And then the loop. Remember, Cx is decreasing as we loop. Next part is the AI2 bit. So that's 13C. And that's it. We store our registers. Return. Now, according to this, our file is 49 bytes big. 1, 2, okay. Oops. Okay. Okay, so now if I click this, switch it on. What I'm doing, click. And I'm doing that. Call 11F. Control C. Do that. Case check. Increment and loop. 1, 2, 3, which is correct. Return. And here's the other function. And there's the return. Make absolutely sure we didn't miss anything. Yeah, there's the final ref. Okay. So actually we're ready to just go ahead and test it. Move into A-3X. CX80. Remember our buffer is at 500, which is less than 0. DX500. We'll see. We put some small letters, some big letters, some non-letters. So I get a good mix. Alright. Now it says I read in 27 characters. Is the carry flag set? No. So we will click. Is AX 0? No. Okay. CX requires AX. We call our function. Saves AX. Saves CX. BX the pointing to our buffer. Now, let me show you what's in our buffer. It's all that stuff I typed, see? Okay. So the first one should be a 73. In fact, it says right here. That's what's going to happen. So ALO, now 73. Is it, we compare with 61. Is it less than 61? No. Is it bigger than 7A? No. So we'll subtract 20 and move it back. I'm just going to show you the first line of the input. Now this will move the new ALO on top of the 73 here, and that should become a capital S. And it did. So it did convert that to capitals. Increment BX to 501. Now, I'm going to trace through the first one. You'll see that the 27 is going to decrement. So now we're back here. Same as before. And if I proceed at this loop, it'll do the whole thing in one go. Okay, so 500. Clearly that's been converted to uppercase, so that part's working. Stored CX 327 we began with. Stored AX 327, return. Now we're back here. The next call, we're just supposed to print it out. Say AX, CX, DX. Again, here DX points at the buffer. A high 2, D low, the value print. and we'll print it an S. Include dx. And again, there's a loop which I can proceed over, and there it is. So it seems to be working. Return and jump to 100 and continue on. Okay, and that's toupper. Now let's see if it actually works for the redirection. Here's something that's upper than 1. I'm going to type it in, and if all goes well, that should just become uppercase. And there you go. It was so fast that you didn't actually see it. It's something that might scroll. Let's see, IMHO might scroll. Okay. So you see, I can take any kind of output and make it become uppercase if I like. So now I can take that to a program. Put this on wherever you programs. And now I've got that forever done. So now, of course, that's only part of what we're trying to achieve. We can now read from DOS, and we got all the redirection stuff. We're printing to the screen. We've done part 3 too. Now, there's no help available for our program. We have no arguments, no switches. For instance, maybe we want to make it do lowercase. All that code is where it's going to be the same if we're doing lowercase as uppercase. There's a few modifications. So maybe we can add some flags and switches. And I was thinking of the possibility of making an even more general filter type program that might do things like, well, you could do spell checking. It's one thing a lot of programs do. But simple punctuation, if you see a period, and if this is a little h, maybe your program is going through and correct those mistakes, something like that. There's no end to the number of things you can do now that we've got easy flow of the data coming in, and we've got a way to modify the data and then print it out. It's just up to your imagination what you want the thing to do. Okay, anyway, I'm going to finish that and then we'll go on to other stuff. So, thanks.